Now I'm going to do problem 1, 4.4 and 4.5. Okay, so let's view the problem. And what we're going to do in 4.4 and 4.5 is to talk about the empirical rule and Chebyshev's rule. Now, the empirical rule requires that the distribution be normal, not skewed to the right or to the left. It's zero skewed, normal. And what it does, empirical rule tells us what percentage of the original data set that we started with falls within so many deviations, standard deviations of the mean. 1 standard deviation of the mean, 2 standard deviations of the mean, 3 standard deviations of the mean. And it tells us, the rule tells us what percentage of the data set that we started with falls within that range of 1 or 2 or 3 standard deviations of the mean. So in this particular problem, problem 1, the average playing time of the musical albums in a large connection is 32. That's the mean. And the standard deviation S is 7. What value is 1 standard deviation above the mean, 1 standard deviation below the mean? What values are 2 standard deviations away from the mean? Well, this is just carrying on some math, and so let's do it. We'll go to the document camera. I'm going to write down, first of all, before we get there, so we know that the mean X bar is, for this problem, is 32, and little s, standard deviation, is equal to 7. So now, let me go to that camera, and you can see I've written it down here. Now we want to know 1 standard deviation above the mean. Okay, well, that's just a calculation. The mean is 32 plus 1 standard deviation is 1 times 7, or in this case would be equal to 32 plus 7, which is equal to 39. Okay. 1 standard deviation below the mean is 32 plus 1 standard deviation, which is, and it's not plus, it's minus. That's we're going below. Minus 1 times 7. And that's equal to 25. Now we also had to have 2 standard deviations. So there's one answer. 2s above the mean. Okay, is 32 plus 2 times 7, or equal to 32 plus 14. okay, which is equal to 46. So 2 standard deviations above the mean would be 46. 2 standard deviations below the mean is 32 minus 2 times 7, which is 32 minus 14. And that's equal to 8. And 18. Okay, let's go back and put those answers in. We had 39, right? Let's see them. 39, 25, 46, and 18. Okay, now. Without assuming anything about the distribution of times, at least what percentage of the times are between 18 and 46 minutes? Well, since we're not assuming anything about the distribution, we're going to use Chebyshev's rule. And Chebyshev's rule, the formula, I'll write it down, then we'll go to it. 100 times 1 minus 1 over k squared. Okay, will give us the percentage. Okay, and we have 18 now and 46. And our mean, I think, was 32, was it not? And our standard deviation is 7. So now let's go to the document camera. I have written, here's Chebyshev's rule, where K is the number of standard deviations above or below. Okay, so we have to determine K in order to work the problem. And then what we get is the percentage of the raw data set that falls between 18 and 46. What percentage of them will fall in between 18 and 46? Well, first of all, we need to find the difference, I guess, between 18 and 32 is 14, isn't that right? On both sides is 14. Well, remember, S is equal to 7, and we want to know how many times 7 we have here. So this is 2 times 7, 2 times 7. So K represents the number of standard deviations above or below the mean, and so the number would be 2. K is equal to 2 standard deviations, because the standard deviations is 7. So K is equal to 2. So in order to find the percentage, we have a 100, 1 minus 1 over 2 squared percent. Okay. So that's going to equal 100 times 1 minus 1/4, because 2 squared is 1/4, okay, which is equal to 100 times 3/4. 1/4 from 1 is 3/4. And that's going to equal 100 times 0.75, because if I divide 4 into 3, I get 0.75. So this is percent. We have it down. So this is equal to 75%. That says that in the range between 18 and 46, which is 2 standard deviations below and 2 standard deviations above, that according to Chebyshev's rule, at least 75% of the original data set items will fall between 18 and 46. Okay. So if we go back to our problem, we have at least 75%. Okay. Now, all these, you'll notice all these problems that you've been working deal with what percentage falls between two things around the mean. Okay. Everything measured around the mean. So now what we want to do, without assuming anything, when you see, without assuming anything about the distribution of times, we're not saying that the distribution, okay, of times is normally distributed. We cannot use the empirical rule about percentages above and below the mean unless it's normal. And we're not assuming anything about it, so we're going to use Chebyshev's rule. And what we're going to do in this one is to find, we want to find the percentage of times that are less than 11 minutes or greater than 53 minutes. Now, that's outside the band between above and below the mean. So what we'll do is find the percentage of above 11 and below 53. And then we'll subtract that from 1, because that'll be 100%. We'll subtract it from 100% actually. And that'll get the percentage outside that interval of so many standard deviations above the mean or below the mean. Okay? So let's set it down. I'll write everything down and then we'll go to the document camera. We have 32. And 32. And we have 11 and 53. Remember, S is equal to 7. Okay. So we're going to have, well, let's go there. You can see me write it here, but make it a little bit bigger. So there's 21, if you subtract, this is 21. That's 32 minus 11. And we have 21 here. Well, 21, standard deviation is 7. So it'd be 3 times standard deviation. 3 times the standard deviation. So we're talking about three standard deviations above and 3 standard deviations below, because the standard deviation is 7. Okay. So K in our problem is 3. Okay. That's it. That's the number of standard deviations. K represents the number of standard deviations we're above or below the mean. Now, when we find our percentage, we're going to find the percentage from here to here. What percentage of the data set that we started with falls between 11 and 53 around the mean? Then what we'll do is subtract that from 100 and we'll get what's over here and over here, because we want it less than 11 or greater than 53. So but we'll find this percentage first, okay? Chebyshev's rule says 100 times 1 minus 1 over K squared. This will give me the percentage. Yeah. Okay. And that'll be like that. Okay. So ours is 100. 1 minus K is 3, so it's 1 over 3 squared, which is equal to 100 times 1 minus 19, which I believe is 8/9, right? We're subtracting 1/9 from 1. And that's going to equal 100 times 0.89%. So that comes out to be 89%. And what do we get? We said that there's 89% of the raw, I call them raw, but the data set will fall between here and here, at least 89%. So if I take that and subtract 100, that from 100, I'll get what's over here, over here. So 89% is 11%. So it says 11% is here and here. Okay. So we'll go back to our problem. We have 11 here. Percent. Now, set enter number, so we might not should have entered the percent, which is probably the number itself. But so anyway, now what we have is in this one, we're assuming that this is a normal distribution. So we're going to use the empirical rule in order to get that taken care of, okay? So, using the empirical rule, what do we know? Well, the empirical rule says that 1 standard deviation above or below is 68% of the data items, raw data items fall between 1 standard deviation above and below. Okay. Now, 2 standard deviations above or below is 95%, and 3 standard deviations above or below is, what is it, 99 point. I have it written down, 99.7, I think it is. 99.7%. Okay. Now, so what we need to do in each one of these is determine how many standard deviations above and below. But we're using now the empirical rule, which tells us, what we have above or below the mean. Mean is 32, remember? So if I go to the doctor and I have the first one is 18 and 46. So I guess that's 14 here and 14 here. Let's go to document camera so you can see it better. Okay, so we have that so far. Okay. Now, well, we know S is equal to 7. That's a standard deviation. So this is going to be 2 times 7. 2 times 7. So we have 2 standard deviations. 2S above and below. Now, according to the empirical rule, if I have 2 standard deviations below and 2 standard deviations above, then the rule, empirical rule, says that approximately 95% of the data items in the data set will fall between 18 and 46. Okay, 95%. So go back, this up. We have 95%. I think we're just supposed to enter a number, really. So I think what we better do is do away with the percent. I think you'll count it wrong if we put the percent in there. Okay, now, less than 11 minutes and greater than 53. That's outside the range. So what we need to do is to find the percentage in the range and subtract it from 1, and that'll give us outside the range. Okay. So yeah, 32. And we have 11 and 53. So now this is 21. The difference between here and here is 21. Between here and here is 21. Remember, S is equal to 7, right? Now let's go to it. See a little better. Okay, now, so that's 3 times 7. 3 times 7. So now we're talking about 3 standard deviations. 3S above and below. And according to the empirical rule, that's 97%. 99.7%. So we know that according to the empirical rule, the original raw data set, 99.7% will fall between 11 and 53. Well, that means 100 minus 99.7, which is equal to 0.3. So 0.3% fall here and here. Okay. Now, we'll just answer this. If 0.3% fall here and here, how many fall here? Well, half of that will fall here. So that's 0.3 over 2, and this is 0.3 over 2. And that's what? 1.25, I believe. So this is equal to 1.125, and this is equal to 0.125. Okay, now let's go back and we'll finish it. This is 0.3, we said. 3. And it's not. I'm sorry. No, this particular one. This is 0.15. According to that, it's 0.15. So the answer to this is 0.15, which is half of 0.3. Sorry about that. Okay, well, that took care of that.